Hi everyone, this is Nilson Lima. I'm here today to show you guys a small tutorial for the new volumetric clouds uh, that will come with release 4.26, and there have been some live streams about this with the Epic stuff, but I thought that I should cover this in detail so everyone can reproduce what was shown in the at the live stream. And I'd like to thank you for Epic for giving us those kind of demos, because it helps a lot for us to build our products. And let's get started. First of all, for this tutorial you need to have the engine built, the 4.26. You have to just get the handling branch, development handling branch inside the GitHub. You have to download the files. You can use the GitHub desktop for this, or Git if you know how to use the command line tool. And once you download the files, you have to run the setup and build the project files. Then you have to open with Visual Studio 2017 and compile. It takes some hours to compile this, depending on the speed of our machine. Can go from maybe 1 hour to 3 hours, or even 4 hours if our machine is really slow. And as you can see here at the top, we are on DirectX 11, so that is not a requirement to have DirectX 12. And I create a small project here with just the 30-person blueprint type of project, and I stripped all the content besides the floor, the stairs here, these elements, and the 30-person character. Network player start. And the cube mesh here, it is called floor here. You can make it really large, so it will simulate a full extent in the horizon, so it will help for us to see the results. And let's start bringing piece by piece. You have to enable the plugin that you found here in the rendering section. The auto day below, and you see volumetrics. Enable this. You ask for you to restart the editor, and you are ready to go when the enter comes back. And right now you have to add a directional light, and this is movable. And for the steps, let's just type pi here. You'll see there are plenty of parameters here. Okay, and let's get left shaft occlusion. We'll see there are plenty of parameters here. It is a atmosphere sunlight because it will act as our sun, so you can enable this. You enable class shadows on clouds, on atmosphere, cloud shadows. The remaining you can leave as it is. So another thing you need a skylight. Bring it here. Let's get our skylight and make it movable. We will enable real-time capture, and cast volumetric shadow, occlusions. You can label this, and we are almost there. You can go to visual effects, and you bring the sky atmosphere. Make sure it rests at 0. And for this, we can like leave all the elements as it is, because there are plenty of things. You see that the floor here, it's so big now that you can, it's like you are in a planet, because it extends, goes through the horizon. So it's like help us to not see the black, it is below the horizon. You can rotate if you want. Sorry for that. You can rotate if you want the light here. You just click on the directional light, and you click here at the gizmo, and you can rotate here if you want. You select the, you can follow by the shadow at your pawn and know where the light is coming from. This is the quick way to do it. And we have set basically almost everything we need. We need to create now here a material. Let's call this material Cloud 01. And now there is for water, clouds, and also for materials describing volumetric fog, there is a new domain. It is volume. You need to select this, and the blend mode will be additive. And furthermore, you don't have to change anything else. Okay. And now let's examine this. We have an albedo. It will basically tell the color for your clouds. MSIV, that is not actually a use for this, but because this is injecting not only color but intensity on your material. In fact, for having a very cheap material, the shading model here can be unlit. And what is important for us here is extinction. Okay, so basically everything we need is to type free and click. So you have here a parameter. Let's call this Cloud Albedo. Let's plug in here. Let's give this a white color. Let's save this. And type 1 and click. We have a 0. Let's put this into extinction. You have to do this, and I'll show you why. Right here we have a type of volume. It's not a volume, it is in visual effects you have a volumetric cloud. So you drag this, and right now there is some some shadowing here because the last tests that we're doing. So you have to place this material you have saved into this slot here. Once you do it, it will clean the sky because we are injecting 0 into extinction. If this is like break saved and you go back, this is what we get. That is a default value there. That is why I have selected 0 here. Okay, so there you go. Now we have a completely clean sky. So this means that anything different from 0 that you are placing here in extinction will be a particle. Let's not call it particle, but it will be considered as vapor to represent our cloud shape. And we can start this very easy when we have selected the volumetric plugin. We have, you click here in your content browser and you go all the way to volumetric content. Click out here and let's see, you go all this way to tools, cloud composite and textures. You have this texture here. So let's add this as a cloud sample. And if you take a look at this, there are just some shapes here. Let's see if it is correct, the data. It seems okay. Alright. So it's like a distant field with very low resolution, but it's all what we need. The size for this texture is quite small. I think it's like 108. It was imported with 64, so that's why they have just so small resolution. So we can have it better, but for our purposes this will do fine. And we have dragged it already here. Another thing, you have to turn off this and select here MIP level. So you see that level will show up here. Okay. Right now what you have to do is better position. Sorry for the noise, guys. And since the world position is giving us the units in centimeters, we have to divide this by a scale. So for us to have a scale, and this is what we are typing here, will be a mask for our clouds. So let's call this mask scale. And for simplicity, like 96, we will type M and click for a multiply. We multiply this by So if you are typing in kilometers, so um, for 1000 you have this in meters and centimeters, so for 100,000, and you click put it in the divide. We have to this is a vector tree, so you have to mask this. So type mask, component mask. We got already masking just the RNG channel. You can place these to the UVs. We can create a scalar here, scalar parameter, and said this will be the mask width level. Let's leave it at 0 for now. And you pick just one of the channels from this texture here, and we place here a subtract. Right now we place a 0 here, and let's place here another multiply, putting our extinction, and another scalar. Let's call this cloud density. Let's divide this by 100. Because we really want to talk values, small values between 0 and 1 for cloud density. And we just place it into this multiply here. So for now, if we save this and go to our map, you'll see that we got some shapes already happening. And in the volumetric cloud component, let me just make this small. You see that layer bottom altitude will change the height we have here. See that for the settings we gave for the directional light, we already have shadows being cast in here in the ground. Okay. And for the cloud height, we can have since we are using a very tiny texture, it is being tiling all the way through the shape. You see that we have the volumetric cloud system is already taking into account that we got a spheric planet, and let's get back to our material. So we see that everything is working fine. Now we have to improve a little bit the cloud layer fall off at the bottom and at the top. for this, you have here a new nodes inside the material editor that are start with cloud sample attribute, and we just need this guy here, learn altitude in layer, and you need 2 multiplies because we want a values for a lower falloff and for the upper falloff. So for one of these, we have use directly the value. To make it the other one negative, we just did 2 minus 1 minus, sorry, and place it right here. And we need to transform this in an exponential falloff, and for this we don't have in the math a function called exponent. Okay, you see that you go to D from floor already, and for this we'll make a custom node, and this custom node you have one input. I'll call this X. For the contents, you just place a return and you make it negative for the input, which is X, and you're ready. You have duplicated this and you place it on each one. After that, you invert both, and you multiply both now, and we want any value which is the maximum between what we have here and 0.01. So we are not accepting zeros passing through this node. And D for divide, we divide 1 by this, another multiply, and we are called this new scalar cloud bias. Let's place a small value here, 0.2, and we will place now this output here into the subtract. And let's save this. We have to place here some values. Let's call the upper falloff for 2, and at the bottom something like 24. It means like a large bottom and a small upper cloud shape. It would be like a cone shape this way, and that is what you see now happening with the regular shape it is applied for the noise. So, and let's just place here, let's make this an instance. and apply this instance here. And let's change some values. So one value that we can already change here is the density, and we already starting to have several clouds being drawn with the parameter we are chasing. The mask scale will show exactly how much you can expect to have, and the upper falloff, you can increase the bottom shape, and the lower falloff, you can reduce the bottom as well. So that's great. Let's come back to our material. Now we have to make these clouds have those cauliflower shapes and at the edges and the bulges in the below part. Okay, and for this we will need some volume textures. The best example, it's again, we go here to the volumetric content. There are some textures that we can use. I'm trying to remember. It's in content, sky, nothing materials. Volume textures. Yes. Volumetric contents, content, volume texture, textures. Okay. So basically, using noise, you create a texture. It is like this one. Let's remove the alpha. And from this texture, check the size. It was created with 4K, and it is square. But you have 16 by 16 tiles that will represent a full volume. Once you have that, you just right click here and type on create volume texture. Once you do that, you have, that is some time for the conversion. You see that both are the same. Okay, and there is an even smaller one here that I think it is this one. It is not inverted, so you can see here it looks like a just a overlay, not inverted, while this texture here, it was used as a overlay inverted, so you have the cauliflower shape done. At least 6 levels, 0.6 of persistence, something like that. And so you got this, and we'll drag it to our material, place it here, and let's place it here. We just need this portion here, but this will be cloud scale, cloud details scale, and stat. Let's pick this. Different from a 2D texture, this texture here, it is a volume. It requires a vector 3, so you just place it here directly. Same approach here, leave the MIP level, make a scalar and call this cloud details MIP level. This is important to tweak the performance just in case. We'll leave it at 0. Just red channel, and we'll subtract 0.5. Well, the values goes from 0 to 1 in this texture, so subtracting 0.5 you can have an adjustment for the amount of details, and we can multiply this when I scalar. It will be our cloud details. Oops. It can be at 0.5. So all you have to do now is place an add here and just multiply right here. So I'll save this, and there you go. You now have more pleasant cloud shapes at your scene. They're static because the mask should be the one moving. You can make both textures move if you want to retain certain basic shapes into your cloud. So you can like have a banner, and so the banner gives let's do something different, because this one needs, with banner you have vector 2 as output, so you need a third for this texture here. So we can control with a 3. Let's convert this to parameter. Let's call this wind direction, and set that our wind direction. When we have x and y at a certain it should define the direction, and for the z it's how much the noise will be moved to the up direction. Maybe this is too much. And we have here the UV. We just add, we have to have some movement, so we need to multiply this by some time period. So you can choose time with speed variable. Let's pick time here, and another scalar for correct would be wind speed, because that's what moves the clouds forward. 0.1. Let's start with a small value. Let's save this. If I didn't miss anything. So now we have, you see that the z movement up mimics like some vapor is going up, so you have some wind that adds up to the upper position, and the clouds move in the x and y direction. You can like change this here, 5. And if you want more detailed shapes at the edges, you need a much more detailed noise here at this, so probably you'll have to create your own noise, pack it into a texture, and increase these detail amounts. I have one I have created, so I can show you how it will look like. It is this one. So if we change it here, save, can improve. Something like that. See, that is even better details here. Basically, the tutorial is like this. You can play with this if you want to, and if you don't have Cloudscape Seasons, be ready that we are releasing update to the asset. It is already in the marketplace, but we will introduce clouds that are such as good as this from Epic, and we will also release a package using these features with the noises that we have prepared to make several types of cloud shapes. And just to see the performance with this amount of clouds, we are having it. That's because I am recording. I think you can expect this material and setup to just use 9 milliseconds, so you have approximately 100 FPS right here. The graphics card I'm using is a GTX 1080, so it's not a brand new, it's quite old already. And the Cloudscape Seasons, I have just 2 milliseconds more than this solution, and we avoid this flickering, and we have a large library of noises to be used to create every kind of shape you want. So stay tuned for the next weeks. We are releasing this, and when the 4.26 launches at October approximately, or November, we'll release a package just for this release of Unreal that you use these new features, because we like it more, how the shadows are cast to the environment, and how the occlusion works. And I hope you guys have enjoyed this, and see you next time. Bye bye.